Hi everyone, this is our first lecture after our campus was closed. So today we are going to continue our discussion of the chapter 8. But before we start, I would like to share verses in the Bible with you. This is in the book of the Psalm 23 verses 4. Even though I walk through the valley of the shadow of death, I will fear no evil, for you are with me. So I know there are anxiety spread out among about society and country, and now most of us are required to stay at home. But I just want to use this verse to encourage you that there's no fear in God. So as a Christians, we should try to learn how to build our faith on God as our basis and try to help each other if we could. So I hope that we can try to practice our Christian faith, especially during this special period of time. So before I start, I would like to show you that the new course schedule. So you can see that we have 5 more weeks left, so which means that some courses material should be abandoned. So we are no longer going to cover chapter 15 and 17. So you can see that the new schedule will only cover up to 12. And the other important change is that originally we have 3 midterm exams, but now we only have 2. And since we already took the first one, and the second one now is going to be scheduled to give at March 30th, and the material covered will be chapter 4 to 7 and 28. So it is slightly different. It is 1 more chapters included. So please pay particular attention to that when you are preparing for the second exam. And we are still going to have our final exam, but now the material will be from chapter 8 to 12. So please follow the schedule here strictly. Especially, we are going to have our first quiz on the Wednesday. So please pay particular attention to that. And the instruction how to conduct your quiz is already written in the email I sent to you on the past Thursday. So when you are doing the homework or you have questions about the quiz or anything, please try to contact me through the email. So now we can now hold the so-called regular office hour. So what I'm going to do is I'm going to check my email address frequently every day. So I will try to respond your questions as frequently as could. So feel free to contact me. So now let's go back to the lecture today. So we have to study about the concept of charge before. So today we are going to talk about the interaction among the charges. So let's try to review the concept of the electric charge. So we know that there are 2 different signs of the charge. One is positive and one is negative. And we also find out that if you try to sum all the particles carry the charges together, then eventually it will be a constant. So this is the meaning of the conservation of the electric charge. So based on the physics law, we believe that constant is a 0. So you can ideally treat that the whole universe, the total charge is 0. But it doesn't mean individually a particle or a galaxy or particles, the charge is 0, okay? So please try to distinguish the difference among these 2 concepts. And we also find out that all the charge carried by the particle is quantized. So what do we mean by it is quantized? Which means that all the charge they carry is in the unit of electron charge. So you will always see which is a particle carry negative electron charge, positive electron charge, or positive 2, negative 2. You never see a particle carry negative 2.5 or negative 3.5 charges. So in that case, what will happen is that during all the physics process, it is about the exchange of the particles cause the change of the charge. So for example, we are going to learn the concept of the atom in the chapter 12, which is a more complicated structure. But originally, atom was built neutral. But when he loses electrons, the rest of particle will become positive charged, and you become the so-called positive ion. So vice versa, if they gain an extra electrons, now the rest of the atoms will become negative charged. So it becomes a negative ion. But when you try to sum all the charges together, eventually it is still neutral. So let's try to study a little bit more about the concept of the conservation of the charge. So as I already briefly mentioned, that in any process involving with interaction of the particles, no electrons are created or destroyed. It is the exchange of the particles. So this is a very crucial concept. So let's use the demonstration I showed you in the class before. If you try to rub the rod with a fur, then originally both of them are neutral, but after that, the rod will carry the extra electrons, which means that there are some electrons was transferred from the fur to the rod. So which means now that the fur will become positive charged. So the summation of the fur of the rod charges eventually will still be zero. This is a concept of the conservation of the charge. So let's try to have our first conceptual quiz. So I will give you a suggestion for the following lecture online. When you are doing this conceptual quiz, you can try to pause the video, think about it, and choose your answer. But now I will simply just go straight to the answer and give you the explanation. So the answer for this question is B. So when we say the charge is conserved, we simply mean that the charge was transferred back and forth. So the concept of the charge here could be a positive charge or could be a negative charge. But no matter what kind of sign of the charge, they cannot be created or be destroyed. This is the key point. So now let's try to study that, the interaction among the different particles carry the charge. So the force experienced based on the charged particles is the so-called Coulomb's law. So did you still remember in the demonstration I showed you in the class, after I rubbed the rod with the fur, they can carry the neutral piece of paper up. So apparently, if I can bring the piece of paper upward, there's an attraction force in between. So this force can be described by the Coulomb's law. So the most important point is that this force always involved with a pair of the charged particles. So the force, the magnitude of the force is proportional to the product of the charges. What does it mean? So you have the two objects with the charge Q1 and Q2. So the magnitude of the force is proportional to the product of the two charges and is inversely proportional to the square of the distance separated. So the further away these two charges from each other, the smaller the forces. And the K is the proportional constant. So it definitely will be provided in the future if you are required to calculate the force. So I'm not sure that, have you already noticed that we have learned this concept before? It is in chapter 4 when we study about the gravitational force between the two particles. We carry the mass m1 and m2. Huh? So exactly the same principle, but they are slightly the difference. So let's try to study the similarity and the difference. So first, the gravitational force we studied before, they only attract each other. But the Coulomb's law, which is electricity, can both attract and repel each other. So this is a very unique difference. So the reason is because the mass is always positive, but the sign of the charge we study, Q1 and Q2 here, could be positive, could be negative. So it depends on the sign of the charge. Then it determines that the force is attractive or repulsive. And the similarity is that the gravitational force and the electric force, they try to act on each other at a distance without in contact. So this is a force in a distance. So you don't have to touch each other. You still can experience the force. And also, both of the forces, the directions is in the straight line between the masses or the charges. So if you have the Q1 and Q2 particle, so the direction of the force in between is simply just you connect Q1 and Q2 together, and the direction is depend on the sign of the charge. And also, we have introduced you the concept of the field. So the force field will surround both of the mass and the charge. So this is a very useful approach later on when we try to study the electric field. So let's try to provide you some pictures about what I just said. So Coulomb's law tells you that if you have two charges, so in the scenario A, you can see that you have the both positive charge. So if you have the same sign of the charge, they don't like each other. So it is a repulsive charge. And how did you determine the directions? Because it is a repulsive charge, so the force Q2 experienced from the Q1 is in the opposite direction along the line connected to the charges. So this is the force experienced by the Q2. And how did you determine the force experienced by Q1 from the Q2? So you can simply just use the Newton's third law we studied before. So these two forces will be the same in the magnitude but opposite in the direction and acting on the different charges. So therefore, you can trivially find out that the force acting on the Q1 is to the left, which is in the complete opposite direction of this force, but the magnitude is the same. And the distance between them will be from Q1 to Q2, which is R. Okay, this is the value you should put when you try to calculate the force for the distance between the two charges. So now let's use the scenario B, which you have the positive and negative charge. So if you have the opposite sign of the charge, then it is an attractive force. Now, they like each other, so they try to get closer. So now the force acting on the Q2 from Q1 is toward to each other. So the same story when you apply the Newton's third law, the force experienced by the Q1 from Q2 will be still in the opposite direction of this force, but in the same directions. So I hope now you have a clear picture at how to decide the direction of the forces. So now let's have the second quiz. So based on the Coulomb's law I just showed you, you have a pair of particles. So now you try to separate them twice as far from each other. Then the force they will experience is what? So the answer, before I show you that, I want you to remind you these equations. The force is inversely proportional to the square of the separation distance. So now the distance d becomes 2d, but you have to take the square. So it is the 4d squared. So therefore, the answer is this, 1/4 as strong, so it becomes weaker. So actually, we have studied very similar questions in the gravity in the chapter 4. So this is actually nothing new, but just apply the same principle. Now, we just introduced you the concept of electric force. Now, what is the so-called electric field? Electric field is different from the electric force. This is a quantity we use to describe that if you have the charge particle here, no matter it is positive or negative charge, what is the intrinsic property, the field produced by him, which can either attract or repel other particles.